These are solutions to problems 87, 91, and 95 from homework 5.4 day 1. In problem 87, we have the natural log of the square root of x plus 2 equals 1. First thing we need to do is undo the natural log. You can do that by rewriting in exponential form or exponentiating both sides. I'll exponentiate both sides using a base of e, because the base of natural log is e. The left side, e to the ln, they undo each other, so that's going to leave us with the square root of x plus 2 is equal to e to the first, which is e. We'll have to square both sides to undo the square root, and that leaves us with x plus 2 is equal to e squared. To isolate x, subtract 2 from both sides, so x is equal to negative 2 plus e squared. And if we enter that into our calculator to get a decimal approximation, it's about 5.389. And since we have a logarithmic equation, we should think about whether that's going to be a valid result. And the square root of 5.389 plus 2 is going to be a positive number, so that's going to be fine. Remember, we can't take the log of 0 or negative values. Number 91. We have the natural log of x minus the natural log of x plus 1 equals 2. Before we can undo the natural log, we'll need to condense. So we'll condense this. This is a difference. So the natural log of x minus the natural log of x plus 1 becomes the natural log of the quotient, x over x plus 1 is equal to 2. Now we want to rewrite this in exponential form. So you can either exponentiate or go directly to exponential form. I'll exponentiate. E to the ln cancels out, so we get x over x plus 1 is equal to e squared. And now we want to isolate x, so we'll multiply both sides of the equation by x plus 1, leaving x on the left side, and then I'll distribute e squared, so I'll have x times e squared plus e squared. And in order to continue to isolate x, I need to get the terms with x on one side of the equation. So I'll subtract x e squared from both sides. So I'll have x minus x e squared is equal to e squared. In order to isolate x, I need to factor out x. So I'll have x times the quantity 1 minus e squared is equal to e squared. And then finally, to get x by itself, divide both sides of the equation by 1 minus e squared. So that means x is equal to e squared over 1 minus e squared. But remember, this is a logarithmic equation, so we better make sure that our answer, our solution, is part of the domain. So if you enter this into a calculator, you'll find that e squared over 1 minus e squared is about negative 1.15, which is less than 0. And if we were to put that in for ln x, we wouldn't get a valid solution. So our answer here is no solution, because negative 1.15 is not in the domain of ln x. So this is extraneous, not in the domain of ln x, or actually ln x plus 1 for that matter. Let's do the last problem on this page. We're asked to solve this logarithmic equation. The first thing that we're going to want to do is condense on the right side of the equation. So we'll have ln x plus 5, and we have the difference of natural logs, which we can condense as the natural log of the quotient. So ln of the quantity x minus 1 minus ln of the quantity x plus 1 is going to become ln of the quotient x minus 1 over x plus 1. Now we can use one-to-one properties. Because we have natural log, we have the same base on each side, means the arguments of the logs have to be equal. So we have x plus 5 is equal to x minus 1 over x plus 1. I'm going to multiply both sides of the equation by x plus 1. And that leaves us on the left side with a quadratic, which I'm going to expand. That's going to be x squared plus 1x plus 5x, which is 6x, plus 5 is equal to x minus 1. And now I'll subtract x from both sides and add 1 to both sides. So minus x plus 1 minus x plus 1 is going to give us x squared plus 5x plus 6 is equal to 0. This actually factors. We're looking for two numbers that multiply to 6 and add to 5. Those numbers are 3 and 2. So that would tell us that our solutions are negative 2 and negative 3. However, this is a logarithmic equation, so we better make sure these values are part of the domain. right? And it's not just that they're negative, it's when we put them into our logarithmic function, is that argument going to be negative? So negative 2 and negative 3 are fine with x plus 5, because negative 2 plus 5 and negative 3 plus 5 will be positive. However, when we have ln of x minus 1, that's going to be negative. We're going to have a negative argument. So negative 2 and negative 3 are not in the domain of ln x minus 1 or ln x plus 1 for that matter. So these solutions are extraneous, and our answer is no solution.